Okay, today is 6.2, day 2. Remember right before break we did day 1 where we learned how to graph ellipses, and today we're going to learn how to write some equations for ellipses. Just as a recap, reminding ourselves what ellipse is. It kind of looks like a circle, except for, we have a major and a minor vertex. Okay, remember the major vertex is the way we extend out the furthest. So if looking at this one on the left, this would be our major vertex. Okay, because it's wider than it is tall, and this would be our minor axis. Over here, this would be the vertical axis would be our major, and the horizontal would be our minor axis. If you look at your formula, very, very similar regardless of which one. Okay, H and K are your center of the ellipse. And then A and B, you know to switch. A is just always your larger axis and B is your smaller one. And that's important for us to help us find what C is, using that formula below to help us find where our foci are. So we learned how to graph some of them earlier, but we're going to go down now and learn how to write some equations. So our first problem, writing the equation of the ellipse having a center at the origin, foci at 0, 3, and 0, -3, and their major axis of length 8. Okay, so one thing we want to start off with is what we already know that's in there. We know that our equation is going to be set equal to 1. And since we're centered at the origin, we're at 0, 0, we know that on top we can just have x squared, okay, and then we can have y squared on the top there. And so we're really just trying to figure out what a and b squared would be at the bottom. Okay, so if you think about, we're centered at 0, 0, and our foci are at 0, 3, and 0, -3. So up 3 and down 3, which means that's going to be our major axis is going to be vertical. Okay, so in this case, A will be underneath your Y. They tell us what our major axis is. Okay. It has a length of 8. That means going from, in this case, top to bottom is a length of 8. So if going from the center up and the center down would each be 4. So that means A is 4. So A squared would be 16. Now, we got to find out what B is. Okay, well, we have A squared. We can use this information here about where our foci is, because remember, you go from your vertex plus C to get to your foci. So our foci here, okay, we had to go up 3, so in this case, C is 3. So C squared equals A squared minus B squared. So 3 squared equals A squared, which is 4 squared minus B squared. So it's 9 equals 16 minus B squared. Subtract that over. And B squared equals 7. Now, B equals square root of 7, that doesn't matter to me in this case because we're not graphing it. We just need to know what B squared is, so we can put that underneath. And there we go. Okay, this equation is centered at 0, 0. The major axis has a length of 8, because it'd be half of whatever your A is down here. Or sorry, in this case, you'd have to find what A is, which is 4, and then double that to get to your 8. And then over here, we have our 7, which is B squared. Okay, which means B would be the square root of 7, and we can go from there if we were having to graph it. Next one. Write the equation of the ellipse with vertices at 4, 9, and 4, 1. It has a minor axis length of 6. Okay, let's think about that. We have 4, 9, and 4, 1. Okay, those are our vertices. Our vertex, or the center, of this shape, okay, would be the midpoint of that. So the midpoint would be 4 plus 4 over 2, comma 9 plus 1 over 2. So 8 divided by 2 is 4. 9 plus 1 is 10, divided by 2 is 5. So our center is 4, 5. So that can give us the top of our equation, x minus 4 squared plus y minus 5 squared. Now, we have to think about how far did we go. So in this case, to go from 4, 5 to 4, 9, we went up 4. And then to go the other way, we had to go down 4. So that means that axis would have a length of 8, which is bigger than 6. So that would make us our major axis has a length of 8. So that means this is bigger than 6, so this is going to be our helpful for us to find what A is. Okay, that's double A, so A would then just be 4. Our minor axis length was 6, so half of that is 3, so B is 3. Okay, so A squared becomes 16. And B squared is 9. Okay, now you have to think about where are these going to go. Well, we had to go up and down 4, so the major axis was your vertical axis, which means 16 would go under the y minus 5, and 9 would go under the x minus 4. Now, there are a lot of different ways to do these, okay? It's just a logical thought process through them, and I think a lot of times drawing a picture definitely help as well. Our last part of day 2 is eccentricity. And we talked a little bit about this on day 1 when we were graphing it. Okay, eccentricity is the constant ratio that we have with our shape here. Okay, about really how round it is. And eccentricity is marked by the letter E. Again, that's not our usual E that we use. And it's always equal to C over A. This value should always be between 0 and 1. And we actually have eccentricity in parabolas. Okay, and a parabola is always 1. And we're going to also learn that we have it in hyperbolas. And a hyperbola actually ends up being greater than 1. So in the following examples, find the eccentricity. So in order to do that, we must figure out what C is and what A is. Well, the first one's already in our normal form. Okay, so we got to figure out which one is our A. Well, the larger one is that. So that's your A squared. Therefore, A is 4. Okay, and then we got to figure out our C by using C squared equals A squared minus B squared. So C squared equals 16 minus 9. So C squared equals 7. So C equals the square root of 7. So E equals square root of 7 over 4. And we can actually do that as a decimal to make sure that we're all good. 7, we get 0.66. Okay, and our last example over here, first thing we need to do is get this in the right form. So we're going to divide through to make sure that it equals to 1. So we're going to divide everything by 50. So it gives x squared over 10 plus y squared over 5 equals 1. So in this case, here is our a squared. Okay, so a equals the square root of 10. And then we go c squared equals a squared minus b squared. So c equals the square root of 5. So c over a, square root of 5 over square root of 10. You could go to your calculator, or remember that's also equivalent to the square root of 1/2, which is about 0.707. And again, it has to be in between 0 and 1, and we have that there. Okay, so today, there's just one problem that you're going to do on Schoology. I just want you to check in with me in some way, whether that be join our Zoom conference, answer a question on Schoology, or even send me an email. Okay, I hope you guys had a nice break, and we can get back to things working a little regular here.